This will be for the con assignment, calculating z-scores. So just a brief overview. A z-score measures exactly how many standard deviations above or below the mean of a data point is. All right, so I'll give you the formula when we start the exercises. All right, and define these symbols. So some facts about z-scores. A positive z-score says the data point is above average. A negative z-score says the data point is below average. A z-score close to 0 says the data point is close to average. And a data point can be considered unusual if its z-score is above 3 or below -3. So typically z-scores apply to a normal distribution. Okay, we didn't cover this too much yet, but a normal distribution is basically like a bell curve. All right, and you can see here the z-score outlined on the bottom. The 0 z-score is around the average. Okay, and when you get into the positive z-scores, that's above average. When you get into the negative z-scores, that's below average. Okay, and you can see +3 and -3 are on the extreme ends of the normal distribution. All right, so just some notes real quick about the formula. The formula for the z-score, it's going to be x minus mu divided by sigma. Okay, so x is just one of the data points. And this Greek letter mu is the mean or average. And this Greek letter sigma is your standard deviation. Okay? So I'm pretty sure for these problems, they will be giving you these 3 values. All right, the grades on a geometry midterm at Springer are roughly symmetric, with mu, or the mean, equals 68, and the standard deviation is 2.0. Emily scored 69 on the exam. Find the z-score for Emily's exam grade and round to 2 decimal places. All right. So the reason they told us that the scores are roughly symmetric is, like I said before, you want to apply the z-score when there's a normal distribution. Okay, so that's why they say it's roughly symmetric. Anyhow, we said the formula for z-score is going to be x minus mu over sigma. Okay, we said x is the data point. So it says she scored 69, so x is going to be 69. And the mean, or mu, is going to be 68, so it's minus 68. And the standard deviation, or sigma, they said is 2.0. Okay, so that's just going to be 1 divided by 2. All right, 69 minus 68 is 1. And 1/2 is the same as 0.5. Okay, it said round to 2 decimal places. I don't know if they want 0.5 or 0.50. I think either one will work. All right, let me just see if they take 0.5. In the box, I'm going to type 0.5. Let me see what happens. Okay. So it was 0.5 or 0.50. All right, same type of question here. Grades on a physics midterm at Covington are roughly symmetric, with the mean equals 72, standard deviation is 2.0. Stephanie scored a 74 on the exam. All right. So I think these will be the same formula every time. X minus mu over sigma. Okay. We said x is the actual data point, so that's 74 in place of x. And mu is 72, that's our mean. And sigma is the standard deviation, that's 2.0. 74 minus 72 is 2. Divided by 2 is just 1. So the z-score is just 1. Okay, it says round to 2 decimal places, but it's exactly 1, so we can just type 1. All right, I'll do one more. I think looks like these are all the same. Okay, the z-score is x minus mu over sigma. Okay, so x is the actual data point. So Ben scored a 71. That's going to be the x value. The mean, or mu, is going to be a 76. And sigma, the standard deviation, is a 3.0. Okay, 71 minus 76 is negative 5. And that's divided by 3. Okay. So this is going to be negative 1.6 repeating. Okay. So rounding to 2 decimal places, you want to look at the third decimal. Okay. And since this is 5 or more, we're going to round it up. So it's going to be negative 1.67. Okay, so just be careful if you have to round it off, because it's 1.66666 repeating. So just look at the third one. 5 or more means round it up. So this becomes negative 1.67. Okay, make sure you get your negative sign in there. Every time I click the box, the screen moves. So negative 1.67. That's the same as negative 5/3.